So, good morning, boys. In
Good
our
morning.
previous class, we completed nomenclature and EAM concepts of our that is complex compounds. Let us take isomerism. Okay,
Sir, from nomenclature, final part, can you please repeat?
I will repeat. You don't worry. Wait.
Okay, sir.
So, isomerism of complex compounds. How to identify the type of isomerism, where isomerism is possible, which type of isomerism. Let us discuss one by one. Here we are going to discuss isomerism, so as much as possible. So see here, my dear, complexes. So here complexes in our syllabus we have coordination number 4 and coordination number 6 complexes are there. So complexes in our syllabus coordination number 4 and coordination number 6. Coordination number 4 means the possible hybridizations are sp3. How that is, I will explain later. sp3 hybridization and dsp2 hybridization. sp3 and dsp2 hybridization. These two are possible. If the complex having sp3 hybridization, that is tetrahedral in shape. If it is dsp2 hybridization, that is square planar in shape. If complex having coordination number 6, it has also sp3d2 hybridization or d2 sp3 hybridization. Whatever it may be, both these cases have octahedral carbon, octahedral shape. Either it is sp3d2 or d2sp3, that should be octahedral. So in our syllabus, we have three types of complexes: tetrahedral complexes, square planar complexes, octahedral complexes. Tetrahedral complexes, coordination number 4 and it seems to be, it is metal. There are 4 coordinate covalent bonds with ligands. I am taking monodentate ligands. This is the structure of our tetrahedral complex. Here, the angle is nearer to 109 degrees, 109.5 degrees. Okay. Square planar complex, there is metal. It has also 4 ligands. All those are within the plane. It is a square planar complex. Here, everywhere the angle is 90 degrees, my dear. Okay. Next, octahedral complex. Octahedral complex means it is metal. These 4 ligands, all these are, I am taking monodentate ligands. All these are within the plane. One ligand above the plane and one ligand below the plane. This is octahedral shape. Okay. These 3 complexes are possible. Okay. Next, in these complexes, what type of hybridizations are possible? Okay. So that is hybridizations are nothing but sp3d sp2 or sp3d2 or d2sp3. So in these complexes, the type of isomerism possible are 2 types of isomerism. One is structural isomerism. Structural isomerism, and the second one is stereo, just like in your organic chemistry, or spatial isomerism. So complexes exhibit 2 types of isomerism: structural isomerism, stereo or spatial isomerism. Okay. Now, first of all, we are discussing here structural isomerism. So in our complexes, structural isomerism, that means structures are changing. Molecular formula, complex formula is the same, but because of structural arrangements are different, those are considered structural isomers, and isomerism is called as structural isomerism. My dear boys, here we are discussing revision part of complex compounds. How to identify which type of isomerism exhibit in that particular complex. That is what I am discussing here. See here, structural isomerism. In your complexes, structural isomerism is different types. One is hydrate isomerism, hydrate isomerism, which is also called as, in place of hydrate, solvent isomerism. Because if water solvent is water, then is hydrate isomerism. Solvent isomerism or hydrate isomerism. Second one is linkage isomerism. Third one is ligand isomerism. Fourth one is coordination isomerism. Coordination isomerism. Next one, ionization isomerism. Ionization isomerism. Next, polymerization isomerism. Polymerization isomerism. Okay, like this, different types of isomerism are possible. All those are structural isomerism. In case of stereo or spatial isomerism, there is two types. One is cis-trans isomerism, and the second one is optical isomerism. This is cis-trans isomerism, also called as geometrical isomerism, which is also called as geometrical isomerism. Let us discuss all these one by one. First of all, I am discussing structural isomerism, different types of structural isomerism. Okay, now see here. See, my dear. First one, I am discussing ionization isomerism. Ionization. See, my dear, ionization, the word ionization in your complex is ionizable sphere, non-ionizable sphere is there. Ionizable sphere is nothing but, in our complex, we can write the complex is within the square brackets and outside the square brackets. Outside the square brackets, what we wrote is considered as ionizable part. Within the square brackets, it is non-ionizable. That means here ionization isomerism is differ at ionizable sphere. Differ at ionizable sphere. Complex having same molecular formula, but ionizable sphere is different. That means when it is dissolved in water, different variety of isomerism. That means different ions are possible. For example, I'm taking CO, Cl, 2Br, NH3, 3NH3. It is the complex, my dear. I can write this complex as CO, NH3 three times, Cl2Br, or CO, NH3 three times, ClBr outside Cl. See, my dear, in these two complexes, one cobalt is there, two chlorines are there, one bromine is there, three ammonias are there. That means these two complexes have same formula. Okay. Now, when these are dissolved in water or any solvent, so it will break down into box ion plus along that Br minus ion. What is this box ion? What is present here inside the box? That is complex entity. That is CO, NH3 three times, Cl2 is there. If this is dissolved, that gives CO, NH3 three times, Cl, Br. Outside gives, it is plus ion. Outside gives Cl minus ion. That means when these two complexes individually dissolved in particular solvent like the water, So this gives bromide ion, this gives chloride ion. That means ionizable part is changed. Am I correct or wrong?
Yes,
Ionizable
sir.
part particularly. Okay, if you identify the test, that means if it is treated with AgNO3, that gives AgBr precipitate. It is yellow in color and pale yellow color and pale yellow precipitate is formed. If it is treated with AgNO3, that gives AgCl precipitate is
White.
formed, which is white colored precipitate. That means both the colors of the precipitates are changed. Even the formula are same, but ionizable part is differ. So that is identified like this. Okay. So that means here say different complexes having same formula, but ionizable sphere is changed. That is why this is considered as ionization isomerism. Clear? That means outside the square
Yes, sir.
brackets is changed. Outside the square bracket. That means ions obtained from the complex are changed. That is why that is called as ionization isomerism. Now let us try to write the name of IUPAC's name of these complexes. See, my dear, this is the complex. It is cationic complex. Cationic complex. First of all, I can write ligands. That is, it is a 3-amine, double M you can use. It is a 2-chloro, that is dichloro. Here C starts, here A starts. Among these two, which one comes first? A. That means
Yes, sir.
triamine dichloro or chlorido cobalt 3 bromide. Triamine dichlorido cobalt 3 Roman letter 3 bromide. Here bromido, sorry, first of all ammonia. Triamine bromido chlorido cobalt 3 chlorides. We can, if more than one ligand is there, we can follow alphabetical order. Ligands alphabetical order we can
Yes,
use
sir.
for writing the name of the complexes. Okay, so this is ionization isomerism. Next and most important one, hydrate isomerism. This hydrate isomerism, see here, when it is possible. When it is possible, because if complex having water, if complex having water molecules as ligands are outside the box are inside the box, now this hydrated isomerism is possible. Without water molecule, hydrated isomerism is not existent. That means existence of hydrated isomerism only in the presence of water. Clear? Only in the presence of water. For example, is this complex exhibit isomerism? That particular hydrated isomerism? Is this complex exhibit hydrated isomerism or not?
No, sir, it will not.
Will not. Why not? It has no water molecules.
No water.
Okay. Okay. Let us take an example. See here. H2O 6 times Cl3, my dear. Cr H2O 6 times Cl3. Now, this is, I can write Cr H2O 5 times Cl chlorine inside it because chlorine can satisfy both primary valence and secondary valence also. It has that much capability and one water molecule outside. Next, Cr H2O 5, so 4 times Cl2 Cl2H2O. Okay, next one more. Cr H2O 3 times Cl3 outside 3H2O. So all these have same formula or same molecular formula or not? Tell me. All these
Yes,
have
sir.
same molecular formula or not?
Same molecular
All
formula.
those have one chromium, 6 water molecules, 3 chlorine atoms. Correct? Now, what is the difference of these complexes? What is the difference? Sometimes water molecule exists in coordination sphere and sometimes in ionizable sphere outside the square brackets. That means water is changed. Particularly here we are discussing about water molecules. So water acts as ligand and also water acts as hydrated condition. These are not ligands, just like hydrates. Okay, so these are complex hydrates along with water molecule only. So that means here these ions, these complexes we collectively consider as hydrate isomers. Clear? Hydrate isomers.
Yes, sir.
So all these have different colors. That different colors have confirmation about existence of these complexes. Existence of complexes. So that means only the change is water in and out.
Yes,
Water
sir.
in and out. Only the
In and out
difference.
the
That
ionic.
is, here isomerism is explained on the basis of water molecules, nothing but solvent molecules. That's why it is called as solvent isomerism. That solvent is water. That's why it is considered as hydrate isomer. Let us take how to name the complexes. Here also naming is important. So here 6 water molecules: hexa, aqua, or aqua, both are same. Chromium, three chlorides. Chromium, three chlorides. Now, what is the name of this complex? Right? Penta aqua, one chloro only. That is penta aqua monochloro or chlorido. It is better to go with chlorido only. Monochlorido, chromium, three, two chlorines outside. That is chloride. I'm writing here. Chloride. After that, one water molecule also there, my dear. You should write number of water molecules also, but here is only one water molecule. It is chloride monohydrate. Monohydrate. That is the name of that complex. Now, how to write the name of this complex? Tetra aqua dichlorido chromium 3 chloride
Dihydrate.
dihydrate. Dihydrate.
Yes.
Okay, now it is tetra aqua trichlorido chromium 3 trihydrate.
Dihydrate.
That means water molecule outside are there. Number of water molecules you should mention in the name. Okay,
Okay,
you
sir.
should mention. So these are all distinguished only according to water molecules. So that's why this type of isomerism is called as ionized hydrate isomerism. Hydrate isomerism. Next, most important third one, linkage isomerism. Linkage isomerism. What is this linkage isomerism? Link. My dear, when this isomerism is possible, it is possible only in the presence of ambidentate ligands. It is important, my dear. At least one ambidentate ligand is exists in your complex, then only linkage isomerism is possible. So in this linkage isomerism, link nothing but bond between metal and ligand changed. Link nothing but bond between metal and ligand change. That's why
Better
this
than ligand.
isomerism is called as. Yes, this isomerism is called as linkage isomerism. That means whenever you want to find out where linkage isomerism is there, so first you search existence of ambidentate ligand. If ambidentate ligand is there
Okay,
in
sir.
your complex, there should be linkage isomerism. If water is there in your complex, there should be hydrate isomerism. Okay, presence of water we can explain
Okay, sir.
hydrate isomerism. Presence of ambidentate ligand we can explain linkage isomerism. Now see here. So ambidentate ligand, let us take an example. CO, NH3 5 times NO2 only. plus 2 iron. It is complex, my dear. What is the name of this complex? Tell me. Actually, it is 5 penta
Pentamine, pentamine,
amine.
nitro.
Amine means here double M or single M we can use
So
while
double
writing
M,
the
double
name.
M.
Double M.
Inorganic is double M.
Amine, pentaamine. Okay,
Nitro,
it is
cobalt,
nitro,
cobalt 3
nitro,
plus
cobalt
3.
3 ion.
Yes, sir.
Because oxygen instead of cobalt here is iron. Actually, this name is wrong, my dear. Okay,
Why, sir?
why not, sir? Why not? It is correct because this NO2 is ambidentate ligand. It has donor atom, maybe nitrogen or oxygen. NO2 like that, like this. N double
Yes.
bond O. Here, nitrogen has lone pair. This lone pair can donate to the metal. Here, donor atom is nitrogen. Okay.
Okay,
Next,
sir.
like this, if donor atom is nitrogen, generally we call it as it is nitro. Donor atom is nitrogen, nitro N is the oxide.
Nitro N.
That means you can mention that donor atom also. Otherwise, ONO also there. ONO. Maybe oxygen is the donor atom. In this case, it is nitro.
ONO.
O is the answer. O. That means link you should mention. Which can donate among those two donor atoms, which can donate. What is emidentate ligand? That has one or more than one donating ligating atoms. Ligating atoms means donating atoms. Well, at the time, only one can donate it, either nitrogen or oxygen, either carbon or nitrogen in cyanide. Okay,
Okay, sir.
so like that. So it has more than one donor atoms, but at the time, only one can donate it. So what is the donor atom you can mention? You must mention. Okay, now the name here, my dear, always if NO2 is written mostly, so nitrogen is the donor atom. If ONO is writing, that is oxygen is the donor atom. Generally, we can feel like that.
Okay, sir.
Okay, okay, now it is nitro N cobalt. Clear? Nitro N
Yes, sir.
cobalt. That means, so whenever ambidentate ligand is there, whenever ambidentate ligand is there, that is expired. The donor atom must present in it. Now, this complex and CONH3 5 times ONO plus 2. These two complexes have same formula or not?
Yeah,
Tell me.
not the same formula. Yes, same formula, but a different linkage point.
Same formula but different arrangements. Clear?
Yes, sir. Yes.
Structurally different. Here donor atom is nitrogen, here donor atom is oxygen. Okay. So my dear, nitro,
Okay,
this
sir.
is also called as nitro O or nitrito. Nitro O or nitrito. Okay.
Okay, sir.
So that means here donor atom is oxygen, here donor atom is nitrogen. That means between metal and ligand, while writing the structure, CO, here NO2, nitrogen with nitrogen, there is a coordinate covalent bond. But in the second case, with oxygen, there is a coordinate covalent bond. That means link between metal and ligand is changed. Am I correct or wrong?
Yes, sir.
Link
Correct,
between
sir.
metal and ligand is changed. That's the type of isomerism is called as linkage isomerism. So in your exams, which of the following exhibit linkage isomerism? That is the question. So where you can search, where it is possible. So find out the complexes given to you. Find out where that ambidentate ligand is there. If there is an ambidentate ligand, that complex no doubt exhibits linkage isomerism. What is
Okay,
ambidentate
sir.
ligand? That is the ligand having more than one donor atoms, but at that time only one can donate. That is ambidentate ligand. Okay, no
Okay,
doubt
sir.
it should be monodentate. It should be monodentate, but it has more than one donor atoms. That is ambidentate ligand. This is linkage as I hope you can understand. Okay.
Yes, sir. 100%.
Next one is ligand isomerism. Ligand isomerism. What is ligand isomer? See, my dear. So complete ligand is changed. Here, ligand is changed. See, my dear. Ionization isomerism, where the change is observed, ionizable sphere. Am I correct? Outside the square bracket.
Yes, sir.
Ionizable sphere is changed, that is why that is ionization isomerism. Linkage isomerism only. Link between metal and ligand is changed, and that is why that is called as linkage isomerism. Hydrate isomerism only. Water is changed, and that is why water in and out is that is position of the water is changed. That is why that is called as hydrate isomerism. That means where we can observe a change, we name that type of isomerism along that change condition. So see here, ligand is changed, that is why it is ligand isomerism. Water is changed, that is why hydrate isomerism. Ionizable sphere is changed, that is why that is ionization isomerism. Link between metal and ligand is changed, that is why that is taken as linkage isomerism. Okay, naming according to the change occurred at that complexes. In that complexes, that is the change conditions. Clearer? What is the
Yes, sir.
name? How the complexes are named like that? So
Yes,
it
sir.
is ligand isomerism is ligand is changed. So sorry, how ligands are changed? Here, the ligand must be an organic ligand, organic part. This organic ligand has isomers. Organic isomers are there. Isomers. So that means here isomers of ligands, isomers of ligands are acts as ligands in the complex, in the complexes. That's why ligands are changed. That's why that is called as ligand isomers. Let us take an example. See, my dear, CO, CH3, CH, CH2, NH2, NH, my dear. Nice. Is a bidentate ligand. Here, both the nitrogens are donor atoms. Okay. So how much is bond number here? Because bidentate ligand, one molecule use two donor atoms, one molecule use two coordinate bonds, total 3 to 6. The coordinate of in this case 6. Okay now. Now, what are those donor atoms? Nitrogen. Nitrogen. Now, what is the name of this ligand? It is organic ligand. Now it is propane. At 1 and 2 positions, amines are there. Propane, 1, 2 diamine. My dear, here only single M. With ammonia only double Mn. For ammonia only double M we can use. Okay. So it is a ligand, my dear. So propane, 1, 2 diamine.
Yes, sir.
Okay. How to name the complex? That is tri. My dear, whenever the word already di, tri are there in the complexes, so if you want to use, that is, if once again we can use di, that is repeated. If di is replaced with bis, already the ligand has the di, tri words. We can use bis, tris like that. So already di is there. It is 3 times.
Okay. This is a
Tris,
tris.
tris, yes, tris, tris. Propane 1, 2 diamine, cobalt 3 complex. It is neutral complex. Tris 1, 2 diamine, cobalt 3 complex. It is the name. See, my dear, the same complex I am writing like this. CH2, CH2, CH2. It is NH2, it is NH2. Once again, it is also the complex end 3 times. See, my dear, this structure and this structure both are same. Structure is nothing but this formula and this formula is same. That means what are those atoms at elements are here in this complex? All those are also here. Cobalt, cobalt, 3 carbons, 3 carbons, 2 nitrogens, 2 nitrogens, all those hydrogens, both are same. Formula is same, but structures are different. Check once. It is propane.
Yes, sir.
1,3 diamine, correct? Propane 1,3 diamine. That means here propane 1,2 diamine, here propane 1,3 diamine. These two are organic isomers or not? Position isomers. Correct or not? In organic chemistry, these two are considered, these two ligands are considered as position isomers.
Positional
Those
isomers, yes.
isomers act as ligand in the complex. Those isomers act as ligands in this complex. Okay, that means ligands are
Yes, sir.
changed. Even though formula is same, but ligands are changed. That isomerism is called as ligand isomerism. That is why that is called
Okay,
as
sir.
ligand isomerism. Clear? That means whenever you want to find out the ligand isomerism, so is there any organic ligand is there or not? If organic ligand is there, so isomers of organic isomers are possible for that one or not? If it is possible, then ligand isomerism is possible. Otherwise, ligand isomerism is not exists. That means isomers of ligands acts as ligands in that particular complexes. Then the isomerism is called as ligand isomerism. Ligand
Okay, sir.
isomerism. Clear?
Yes, sir.
So if you want to find out, hydride isomerism, find out what is there or not. If you want to find out linkage isomerism, find where that is embedded ligand is there or not. If there, linkage isomerism is possible. If not there, not possible. And water is there, hydride isomerism is possible. If water is not there, hydride isomerism is also possible. That means ligand isomerism. So if ligand, organic ligand with isomers, then ligand isomerism is possible. Organic isomer, organic ligand is there, but no isomers are possible. Not possible. Organic
Okay, sir.
ligand with isomers are possible, then ligand isomerism is possible. There is a way to search whether it is possible or not possible. Next, coordination isomerism. Coordination isomerism. What is this coordination isomerism? Here, my dear, already the word is used coordination. That means coordination speed is changed. Ligand isomerism, ligand is changed. Hydride isomerism, water is changed. Linkage isomerism, link between metal and ligand changed. Now coordination isomerism, coordination speed is changed. Coordination speed is nothing but coordination entity. Coordination entity is nothing but within the brackets. Within the brackets, part is changed. Okay. If outside the bracket is changed, ionization isomerism. If within the bracket is changed, coordination isomerism. Ionizable sphere, non-ionizable sphere. If ionizable sphere is changed, that is ionization isomerism. If non-ionizable the sphere, that is coordination sphere is changed. That is called as coordination isomerism. Okay. So let's see, my dear. Here, when it is possible, here both cation and anion are complex ions. Cation should be complex ion, anion also complex ion. Order ions are not exist. Both cation and anion are complex ions. For example, CO, NH3 6 times, and Cr, Cn 6 times. See, my dear, it is totally a single complex. Okay, here cobalt has +3 oxygen state. Here chromium has also +3, but cyanide, Cn has -1, 6 -1, 3 plus, overall it is -3. Okay, +3 and -3 neutralize. That's why it is the complex. Clear? So that means here cation is complex, anion also complex. It is nothing but polynuclear complex. Polynuclear complexes. Okay. So in this polynuclear complex, both cation and anion are complexes. Then we can identify coordination isomerism. Only one coordination is there. That is not possible.
Yes, sir.
That means, see here, I can exchange this one. CO, NH3 5 times Cn. plus 2 Cr Cn 5 times NH3 minus 2. It is a plus 3, it is minus 3n. And now find out all these present in this complex are also exist here. Am I correct? Here 6 cyanides, 5 plus 1. 6 ammonias, 5 plus 1.
Yes, sir.
Okay. Next,
Yes.
I can write once again CO NaH3 4 times Cn twice plus 1. Here Cr Cn 4 times NaH3 twice minus 1. Okay now. Now once again.
Yes, sir.
CO NaH3 thrice Cn thrice. See my dear, in this, is there any charge on this complex? Existing charge is there or
There
not?
will be no charge.
No charge. It is zero only.
Yes, sir.
Cr Cn 4 times sorry 3 times NaH3 thrice. Is this has any charge in this box?
No charges, sir.
No
This is the
charge.
same compound.
Okay. Next. See once again. Wait.
Okay.
Later. Once again exchange. Exchange is there. Now CO NaH3 2 times Cn 4 times. Now minus 1. Correct? Cobalt plus 3, 4 cyanides. Here it is Cr, Cn twice, NaH3 4 times, plus 1. Chromium plus 3, cyanide minus 2. Override is plus 1. Next, CO, NaH3 1, Cn 5 times, minus 2. Cr, Cn 1, NaH3 5 times, minus plus 1. Last, CO, Cn 6 times minus 3. Cr NaH3 6 times plus 3. Okay. See, my dear, here both the metal atoms are different. Otherwise, it is not possible. Only. Both the metal atoms in the complex are different. Complex entities are different. Ligands are also different. But entire complex is same. Okay, single complex. See, my dear,
Yes, sir.
in these complexes, these are charged rate. That means plus 2 minus 2 exists. Plus 1 minus 1 exists. 0 and 0 exists or not exist?
Sir,
These
this
two
one
combinations exist or not exist?
does not exist.
Does not exist. It is not considered as combination, this set of these complexes. Now these three are exist or not?
Yes, sir. Exist.
Exist. Now how many coordination isomers are possible with this complex?
Sir, there will be two per compound.
No. 1, 2, 3, 4, 5. Total 5
Oh.
coordination
10.
Total 5. So it is not 6, my dear. Okay. 5 complexes we can write. 5 complexes we can write. Okay, na?
Sir,
Number of
confusion.
is there any confusion?
Yes, sir. Sir, how did you take out like 5? Because
Yes.
it won't it be double the number?
All these 5 have same number of cobalt or not?
Yes.
Same number of ammonia or not?
Yes.
Same number of cyanides or not?
Got it, sir.
No
Okay,
doubt all
got
these have isomers, am I correct?
Yes.
But
Exactly.
coordination entities are same or not? Coordination entities are same or not in these complexes?
Not same, no, not same.
Not same. That's why there is a coordination isomerism.
Okay, sir.
How many coordination isomers are possible with this complex?
Sir, 5.
5. So how much is the coordination number here? 6. If 6 is the coordination number of coordination isomers is equal to coordination number minus 1.
Okay, sir.
Because one should be neutralized. It is neutral. It is not complex. One
Okay,
should
sir.
be neutralized. Okay. So that is why answer is 5. Clear?
Yes, sir.
Next.
సార్ ఒకసారి లాస్ట్ ఎగ్జాంపుల్ ఎక్స్ప్లెయిన్ చేయండి సార్. మీరు ఇప్పుడు
Yeah.
చెప్పేసి
Oh, too late. CONH3 three times CN, three times. Cr and Cn three times. NH3 three times. Okay now.
ఓకే సార్.
So if this complex, this set is exists, one should plus, one should minus. Otherwise, the set is not exist because there should be a ionic part. Then only attraction is possible.
ఓకే
But here, cobalt has plus 3, ammonia has 0, cyanide has minus 1 into 3. Overall, it is neutral. Correct or wrong?
కరెక్ట్ సార్.
So it has no charge. Like this, here also no charge. Because these two have no charges, between them no attraction exists.
ఎస్ సార్.
So that's why these two complexes not collectively exist.
ఓకే సార్.
Both these are same. Both these are same.
ఎస్.
So that's why it is 2 times of CONH3 three times CN thrice. It is a neutral complex set. It is not like that. That's why it is not considered as one of the isomers of these sets.
ఓకే సార్.
Okay. Shiva here?
Sir,
Shiva is there.
yes, sir, there's
When you came here,
525.
it is too much late.
Yes, sir. Sir, laptop open wala sir. అందుకే లేట్.
Okay. Polymerization isomerism points. It is last one, I think. Polymerization isomerism means here molecular formula not same first of all, but empirical formula same. Do you know the difference between molecular formula and empirical formula? Molecular
Yes,
formula
sir.
is nothing but exact number of atoms of an element are exist. Here, formula exists with simple ratio of atoms of elements. Okay, na? So actually,
Yes, sir.
C6H12O6 is the molecular formula of glucose. It is the molecular formula of glucose. But
Empirical
CH2O is the
Yes.
empirical formula of glucose. Okay, na? That
Yes,
is,
sir.
it is atoms are in the simplest ratio. It is exact number of atoms are exist. And with exact number of atoms, that is molecular formula. With ratio, simplest ratio, that is empirical formula. Here, molecular formula is not same, but empirical formula is same. Let us take an example. In these complexes, see my dear, PT Cl4 minus 2 exists. Okay, now I'm taking PT. Just a minute. It is better to take some general example, my dear, not exact example. So there is a metal with ligands, my dear. With 2 ligands, a complex is there. Next, same metal, okay, M2, L4 times exists. Or M3, L6 are exists. Clear? So
Yes, sir.
same metals, but it is 1 times, it is 2 times, it is 2 times, 4 times, 3 times, 6 times. For all these, ML2 is the empirical formula. Correct or wrong? For all those,
Correct, sir. Correct, sir.
ML2 is the empirical formula, but their molecular formulas are same or not same?
Not same.
Not same. That means like these complexes are there. Like these complexes are there, then that isomerism is considered as this is a polymer. It is 2 times, it is 3 times like that. But it is dimerized, it is trimerized of this one. Okay, na? That is considered as polymerization. That is that isomerism is called as polymerization isomerism. Clear? That isomerism
Yes,
is
sir.
considered
Yes,
as
sir.
polymerization.
ఓకే సార్.
Yes, sir.
అర్థమైంది.
Okay.
Okay. Next, one more type, that is coordination linkage isomerism. Coordination linkage isomerism. My dear, here the two words are used: coordination and linkage. That means coordination sphere changed and linkage between the metal and ligand also changed. Link between metal and ligand also changed. That is why it is coordination linkage isomerism. Okay, now see here. This is I am taking
Yes, sir.
CO, OH, OH, Cr, NH3 4 times, C, NH3 3 times, Cn, my dear. It is Cn 3 times NH3. This is the complex, let it be, my dear. This is my assumed one. These two OHs are in bridge condition, correct or wrong?
Yes, sir.
Okay, it is in bridge. Okay, so while writing the name of this bridge, mu hydroxido, what is used? And mu is used. Anubhav, that is what you asked. While writing the name of the bridge
Exactly, sir.
ligands,
Exactly, sir.
while writing the name of the bridge ligands, mu letter is used. Mu letter is used. So mu, whenever mu is there, that should be that ligand is in bridge position.
Okay.
Okay. Okay, now this complex, my dear. Here, cobalt linked with 3 cyanides and 1 ammonia. Here, chromium, 3 ammonias with 1 cyanide. Just I am changing this complex CO, OH, Cr, OH, like this. Next, Cn 4 times. Here, NH3 4 times. Okay, now. Both are same. Check once. Here, coordination sphere changed or not?
Yes, sir.
Coordination
sir.
sphere changed or not? Within the brackets, it changes. And also linkage, and you want linkage. See, my dear, here, bond between carbon and metal having bond between with carbon of cyanide atom, cyanide ion. Here, link between carbon and carbon cobalt. But here I am writing Cn 1 with nitrogen and carbon. Donor is nitrogen atom, my dear. Here, link between metal and ligand is changed or not in this case?
So this became an isonitrile.
No doubt, it is
Yes.
embedded ligand. Cyanide also
Yes, sir.
embedded ligand.
Yes, sir.
Okay. Here, between carbon and cobalt, there exists metal ligand bonds. Here, nitrogen and carbon, there should be metal and cobalt. There should be a link between metal and ligand. That means ligand link is changed or not.
Yes, sir. Change.
So coordination sphere changed, link also changed. Okay, that is what is called as coordination linkage isomerism. Like this also happened. Like this also happening. Okay, now. So this is number of times they ask some more different combinations. They also ask that. They will ask.
Okay.
Okay.
Okay, sir.
Okay. This is the end of structural isomerism, my dear.